Okay, ladies and gentlemen, this is 8.1, apply the Pythagorean theorem. So a couple of notes just right up the top is about the Pythagorean theorem. And what we're going to do first is we're going to draw a very simple, small, right triangle. Okay, try and make it so that it's not isosceles. Try and make it so that the two legs, A and B, are different lengths. And we'll label them A, B, and C. So you can see that the 90-degree angle is across from side C. Do you know what side C is called?
Yes.
It's called the hypotenuse. It is related to slope. We deal with that next year mostly. But it is the hypotenuse. You're going to have a small set of notes here and a small set of notes here, and it's all going to fit in that top little space that you have, okay? So the hypotenuse is the longest side of a right triangle. The longest side of a right triangle. It is opposite the 90-degree angle. Okay? So on your diagram, if you'd like to, you can go ahead and kind of highlight that with another color. But C, length C there is the hypotenuse. Now it doesn't matter which way you draw the triangle. I can draw a right triangle upside down. I can draw a right triangle backwards. Whatever it is, the side opposite the right angle is the hypotenuse. Okay? So in every situation, you should be able to identify the hypotenuse in a right triangle. Does a non-right triangle have a hypotenuse? No, it does not. It has to be opposite a 90-degree angle.
Oh, yeah, 'cause it's
Excellent.
a right
Thank you
triangle.
very much. Now we also need to know a little bit about Pythagorean theorem. So I'm going to write it, and then we'll put a couple of notes about it. So all it basically says is a squared plus b squared equals c squared. This is a way of relating the side lengths in a right triangle. Does this a squared plus b squared equals c squared, does it talk about angles at all? No. It talks about side lengths in a right triangle. Is it still true in a different kind of triangle?
Yes.
No. It is in a right triangle. Okay. I'm glad we clarified all that. Here's a couple notes. In a right triangle, the square, and this is going to be a bit wordy, but it will make sense once we think through it. The square of the length of the hypotenuse, I'm just going to use hype. In a right triangle, the square of the length of the hypotenuse is equal to the sum. Does anyone know how to finish this sentence? So far we have the right side of the equation. We have
It's
this.
equal to the left side of the equation.
The
Well-
sum of b squared.
A squared plus c squared.
Good. So did we use c squared in the first part of our definition? No, we didn't.
Is equal
So
to
it's
c squared.
the square of the length of the hypotenuse, that's right here, is equal to the sum of
Other two lengths.
the squares of the,
Other two lengths.
alright, here we go, of the two shorter sides, is equal to the sum of the squares, because you have to square them first, of the two shorter sides. Okay, so again, to think through that a little bit, we have the square of the length of the hypotenuse, that's right here, c squared, is equal to the sum, that means we're adding things together, of the squares, that means we took the squares of the two shorter sides. Okay, so you have to take the squares first, then add them together. If you do that, it'll be the exact same as the square of the third side of the hypotenuse, which is the longest side.
Wait, so
are
you
you
take
saying the length of A and the length of B are equal to the length of C?
No, I'm not saying that. I'm saying that this is not true. Okay? It does not say that. You have to, because of bed mass, because of order of operations, you have to first square A, square B, add them together, and that will equal the square of C. Okay, we're going to watch a short video through Math Antics that's going to help us understand that a little bit better. Alright, let's get into a couple of examples. First one is example 1, and all we're asked to do is find the hypotenuse. If we read that little situation, it says the advertised size of a computer screen is actually the length of the diagonal of the screen. Okay, so when you buy a 32-inch TV, that's the measure of the length of the diagonal across that screen. Okay? No, it's just how they're measured and how they're advertised. Okay, a computer screen measures 30 centimeters by 22.5 centimeters. Determine the length of its diagonal. How would we do this?
By using the Pythagorean theorem.
Using the Pythagorean theorem. Basically, we can take this rectangle and we can draw that diagonal using a ruler. And now what we've done is we've split that rectangle into two right triangles. Okay, and I can use either one to solve. It makes no difference. Because the computer screen is a perfect rectangle, I know that this side is also 30 centimeters. And over here, this side is 22.5 centimeters. So why don't we focus on this triangle down at the bottom. And we've got our Pythagorean theorem, which is a squared plus b squared equals c squared. And we know the base, we can think of it as base and height, or we can think of it as A and B, so our side lengths. By the way, which line in my diagram represents C?
The middle.
The diagonal.
Yeah, the diagonal, because C is always the hypotenuse. And it doesn't matter what I call A and B, as long as I'm consistent. Okay? So here we will sub in what we know. So for A, we sub in 30. Now,
30 squared, no?
that's right. No, for A, we sub in 30, which means we still have that squared symbol. Okay? So we leave that there. For B, we're going to sub in 22.5, and we're going to have to square that. And that's going to equal C squared. Anyone have their calculator out?
900.
So we've got
30.
900.
And then 506.25.
506.25.
How many decimal places can you do?
In this case, there are only two, so you may as well keep them all.
C is 1,400.
Careful. C is not that.
Oh,
answer.
no.
You have
Okay,
to.
so let's do this. Let's just do it together in order. I'm going to add these up. So it's 900 plus 506.25.
1,000 times itself. Right? Yeah.
No. And I'm going to swap sides here. I'm going to just rewrite this so that it's C squared is first. So we have C squared equals 1,406.25. Now we're not done yet.
They're all, both of them are
What?
squared.
We need to take the square root
That's what it's
of both sides.
Can we just leave it like that?
On the left side, the square root of C squared is just C. And on the right side, the square root of 1,406.25 is
1,406.3.
37.5.
What? And we just do the square root of 1,406.3.
No.
How did you get 37?
That's what he said we can do.
Okay?
I thought it was this.
So, yeah, if you are measuring a computer screen or a TV screen, you would not leave it as the square root of 1,406.25. You would actually take the square root of it and round it to one decimal place, which is really nice. And we'll put our units here as well. So the diagonal of that screen, the length across the diagonal of that screen is 37.5 centimeters long.
When we went to last
All right,
year,
example 2 is about Jenna. So Jenna is replacing a light bulb. And here's the lantern here. Jenna is changing a light bulb. She rests a 4-meter ladder against a vertical wall so that its base is 1.4 meters from the wall. So where do I label my length of 4 meters?
In the bottom. From the wall.
What
She
length?
has
I
a
guess
4-meter
against the wall.
ladder.
Oh,
against
the
wall.
ladder is
Is
4 meters long.
Oh.
So in this scenario, we're given the length of the hypotenuse. Now, where does that 1.4 meters come in? That's at the bottom, the distance from the wall. Okay? So here we go. Again, we need to find out how high up the wall does the ladder reach. So we're trying to find this length. And we're going to label our sides so that we can use Pythagorean theorem. What's the Pythagorean theorem again?
A squared, B squared equals C squared.
Alright, and which lengths do I know?
C and A.
That's right, we know C, and you can call this A, that's fine, then that would make this side B. You could do it the other way around too, it makes no difference as long as the hypotenuse is 4 meters, okay? The hypotenuse is the longest side, so that has to be whatever letter you choose to use. It's going to be by itself on this side of the equation. Okay, so let's sub in what we know. A is 1.4, don't forget your squared. We don't know B, so we'll just copy down B squared. C is 4, don't forget the squared sign. Alright, let's simplify first by by squaring the numbers that we know. Okay, so we're dealing with the exponents first. 1.4 squared is, shall I have your calculator out?
1.96.
Good, 1.96. We plus B squared, and 4 squared is 16. Now, how are we going to isolate B?
By minus 1.9.
We're going to subtract 1.96 from
16.
both
From both sides.
sides. If we do one thing to the one side, we have to do it to the other side. On the left, we're just left with B squared, and on the right, we're left with 14.04. Okay, don't round too early. Keep all your decimal places. You'll round at the end if need
Do we
be.
need a sentence at the end?
So now what's our next step?
Square root.
I need to take the square root of both sides.
Left with B.
On the left side, we just have B. On the right side, we have...
3.7. That's number, so just 14.04.
Good, so I'm going to use B as approximately. Our approximate sign there is approximately 3.7. And I'm going to remember my units. And I'm going to put that into a sentence. Jenna's ladder will reach 3.7 meters up the wall. If you're not sure what your final sentence should say or what it should be talking about, just take a quick look at your diagram again. This is the length that we were looking for. It's the height of the ladder, how far it stretches up the wall.
Oh, I thought we were
Okay.
going to find half the length of the ladder.
Okay, last example. Calculate the area of a right triangle in this sailboat. So we have a toy sailboat, and we need to calculate the area of the sail. So we're not just talking about the Pythagorean theorem now, because we're talking about area. What's the area formula for a triangle?
Base times height.
A equals B times H.
Does anyone know the area formula for a triangle?
1/2.
One half.
Okay.
Base times height.
Okay, everyone relax. Okay.
Thank you very much. All right, so in order to use this formula, we need, guys, in order to use this formula, we need the base and the height of the
So
triangle.
we use the Pythagorean theorem first.
That's right. So if we look at our toy sailboat, we're given the hypotenuse and we're given the height, but we are not given the base of the triangle. So let's go ahead and use our Pythagorean theorem in order to get the base of the triangle. I'm going to let you do it on your own, and then you can check the board in a second. Okay, hopefully you've had a chance to do it. I'm going to work through it now as well. So I'm just going to sub in what I know from this triangle. I know that C is 11. I'm going to call this side length as B, so that's 8 squared, and I don't know what A is, so I have A squared. So again, because of the order of operations, I'm going to just deal with my exponents first. So on the left, I have A squared plus 64. On the right, I have 121. Now I want to isolate a, so I'm going to subtract 64 from both sides. That's going to leave me on the left with just a squared. And it's going to equal 121 minus 64, which is 57. And then I'm going to take the square root of both sides. The square root of a squared. So if I have a and I square it and then square root it, it's just a. And the square root of 57 is approximately
7.5.
7.5. Okay? Now I can add that to my diagram if it helps me. Now I get to jump into my formula for the area of a triangle. I'll just move over here. Area equals 1/2 base times height. And I know that my base now is 7.5. And I know that the height is 8. So I just chuck that in my calculator. 7.5 times 8. Get the answer. Divide by 2. And it's 30. Okay? Now when I write my sentence, I have to remember what I'm talking about. I go back to my question. It says calculate the area of the sail on the toy sailboat. So the area of the sail is, and I can't say it's exactly 30 because I actually rounded over here to get my base length, is about, or approximately, is about 30. And what is it measured in?
Centimeters.
If my side lengths are measured in centimeters, but now I'm dealing with area, it's good. It's square centimeters, or you can write it as 30 centimeters squared. Okay? Either of those is good. Excellent. Quickly reviewing the key concepts that we went through today. The longest side of a right triangle is called
The hypotenuse.
the hypotenuse. The Pythagorean theorem states that the square of the length of the hypotenuse is
equal to
the sum of the squares of the lengths of the two shorter sides, which in algebra means c squared equals
B and A.
c squared equals a squared plus b squared. Good. And you can use that to calculate any unknown side of a triangle as long as you have the two other sides. Okay, your practice problems are written for you at the bottom of your page there. They come from your textbook again, from page 473, numbers 1 through 17, and number 19. Okay, number 19 says to do it with a partner, but you'll be doing it at home, so you'll do it on your own, and then we'll just test our answers with each other when we get back tomorrow. Go for it.